Anna Savaco. I'm the Education Department Manager here at the Door and Hardware Institute. And on behalf of myself and our entire education team and everyone out here, we just welcome you here today. I am very pleased and excited to announce our presenter for today, Mr. Al Urbaniak. He is the Knowledge Center Implementation Manager for Allegion and has held several positions, including Product Support Manager, Product Manager, and Director of Marketing. He is an active member and participant in both the Hollow Metal Manufacturers Association and the Steel Door Institute. He currently serves on several committees for both organizations. He has published articles in several trade magazines and develops and conducts several training sessions for the industry and various trades. So I welcome you all today. Today's webinar, Al, if you want to go to the next slide, that'd be great. Here we are. It is worth 3 DHI CEP points available today for this presentation. Most importantly, make sure that you have muted your speaker's microphone. Everything should be muted so we can all hear Al's presentation. It will be recorded, available for members, and you can see the directions there right on the slide. Today's presentation will be an hour with a Q&A session at the end. There will be a chat question box on your screen to the right, and like I said at the end, you'll have time, and we really welcome questions. So without further ado, I'm going to present it over to Mr. Al Urbaniak. Thank you, Al.
Thank you. Thank you, Hannah, and thank everybody for attending this session. I really appreciate you taking the time away from your businesses. And this course is on installation and storage of hollow metal. And it's a pretty detailed course, and I'll really touch on the necessary precautions and requirements for successful installation of hollow metal. And then the proper job site receipt and storage, which is the contractor's responsibility. And then I'll go through the correct installation. I'll touch on the process somewhat. We'll talk about the anchors and the different methods depending on wall construction. Now, as I mentioned last week, for those that attended last week's session, HMMA 840 and all literature published by HMMA is available at no charge from hollowmetal.org. And I'm not sure who is familiar with that website. It is in the process of being redesigned, and we should have a new website up probably in the third quarter of this year. But on the website, hollowmetal.org, in the left-hand banner, you'll notice an area called Technical Literature. When you click on that, you open up the library of literature, and you can just click on the PDF downloads and download any standard specification or technical tip. In this situation here, we're talking about HMMA 840, I'm sorry. Now, this does cover total installation and storage of hollow metal, and the current edition was published in '07. We should have a brand new edition of this. That would be the 14 edition, which will be published in hopefully the second or third quarter of this year. Now, in this presentation, using the 840 as a guideline, we'll touch on the contractor's responsibility, which is the main responsibility of installing the hollow metal. Then we'll talk about the installation process, like I said before, some anchors and wall construction. And then we'll end up with some technical news items, technical tips that relate directly to installation and storage. Now, looking at job responsibilities, like I said before, the contractor has the main responsibilities, and that is receiving the material, inspecting it, proper storage of the product, which is critical, and then the proper installation of the product. Now, these items, this presentation deals with hollow metal, but those three items are really critical for the contractor for all building products, including all your hardware, partitions, etc. They've got to follow those three items mainly. Now, at the same time, distributors are really the people who are involved in visiting the job sites, inspecting the material to make sure everything's okay, and they're consulting really with the GC or the building owner, architect, and their responsibility really is to ensure that everything is going good, because that step really offsets long-term back charges, which are very critical in the construction process, and it's the manufacturer's responsibility, along with distribution, to do everything we can to offset any type of future back charges. That's a lot of this standard that we're going to talk about. Now, in the contractor's receiving or his responsibilities, the first thing is receiving and inspecting the material. Now, the contractor really has the responsibility to look at the material and decide whether he wants to accept the material as is, or refuse it, or accept it as damaged. Now, this is a picture of one of the loads that comes into a job site, and just looking at it, when the contractor opens the doors, they have to realize something could be wrong in that load. And they should be notifying the distributor or the manufacturer, depending on what the channel is supplying, of any kind of defects. And their responsibility, again, is either to accept the load as is, and then they have total ownership of it, or reject the load. And that's critical, and that's the very first step to offset any kind of back charges. Now, the next item that is critical is the storage of the product. And in any of the installation standards, the key is to store the hollow metal, and it also relates to hardware, any building products, in a protected area away from weather. Now, HNMA 840 has a pretty detailed list of the storage steps involved. And basically, it's storing the material upright in a protected area away from weather with air ventilation around the product. Now, those steps are really typical of HMMA or even SDI. It's critical steps in storage. Now, I talked a little bit about visiting job sites, and any type of material supplier's sales force should periodically go to job sites with the distributors and see what's going on. These are some photos that were taken by distribution of job site storage. As you can see, it's not protected. It's not properly stored. This type of storage really relates to back charges later in the job site, and the contractor will usually use the crutch of poor paint or defects in the paint, etc. But the key is, in visiting job sites, if you see anything like that going on, take a picture and store it with your phone or any kind of camera, and just keep it for future protection and offsetting of any type of back charges. Now, installation of the product. When you look at back charges related to hollow metal or even hardware, it relates mainly back to some type of installation deficiencies. Now, there's no doubt that manufacturers do have quality issues periodically, and hopefully you're dealing with a manufacturer that takes care of those deficiencies. But in functionality, most problems relate to installation deficiencies. Now, in installing the products, trying to offset any kind of deficiencies, the first step really needs to be for the contractor to make sure that they check the mark numbers, check the size and the swing. Because usually in jobs, you'll end up with a door short or a wrong door going into a wrong frame. What that relates to in most cases is the fact that the wrong frame was installed in the wrong opening. So it's critical for the contractor to check the mark number, the size, and swing of the opening. The next thing prior to installing, the shipping bars must be removed from welded frames. Now, that's just a temporary spreader. A shipping bar, all manufacturer instructions and industry standards clearly recommend that those shipping bars must be removed. They are not an installation spreader. The next item is starting to install the product, where you locate the frame where it will be installed in the building. And the first part of that is for the installing contractor to have properly sized spreading boards. And these would be mainly wood spreaders that are cut to the exact size of the opening, and they're first placed at the bottom of the frame. The next requirement for spreaders is that a mid-height or a lock level spreader device be installed in that opening. Now, when we're talking about these type of items, we are currently focused on frames going into masonry type construction. We'll talk about stud walls and that a little later in the presentation. But in the masonry type walls, the frame is located in the opening prior to any type of wall construction being made. Now, after it is located and positioned, the frame is squared and braced so that the installation is proper. From there, if this is a larger type opening, an additional spreader is installed above the lock level. Now, before like anything above, say, 8 foot. For side light frames, spreaders are also installed prior to the wall buildup. Then we go into the leveling and squaring of the opening, and this is done usually with an actual level and T-squares. Your laser levelers are now starting to be used more and more, but it's critical that the frame, prior to any type of anchorage and wall construction, the frame be leveled, adjusted, and squared. From there, the carpenter or the installing contractor is squaring for plumbness and alignment. In this part of the installation, the sills of the frame, the very bottom sill anchors and the base of the jambs, they should be squared and leveled. And in this area, you're using a actual carpenter square where your laser leveling devices need to be used so that the bottom of the frame is square and aligned with the head. Installation tolerances are clearly documented in all industry documents and manufacturers, and proper installation really is critical for long-term life of the door operation in the frame and even hardware. If the correct clearances are not really maintained, there will be interference with the door, there will be excessive shimming, and that'll all lead to quick wearing out of the door and the hardware. So the tolerances are critical, and they are published by HNMA in the standard 840. Now, moving from the high-level installation concepts, we're going to look at some anchoring systems. And with that, these are all covered in 840. The key idea between the anchoring is the proper anchoring must be used for the wall. The anchors are designed specifically for the wall construction, whether it is masonry or stud wall. Variations in the details and the designs that we're going to go through in this presentation will exist depending on the manufacturer. But performance of the anchor and the frame in the wall is critical based on the proper anchor selection. Now, location of the anchors are clearly documented by HMMA and also the manufacturers. In HMMA in Table 1, it's a clear guideline of anchor spacing, and that's all in accordance with NFPA Pamphlet 80 and building code requirements. The key here is that the number of anchors shown relate to jam anchors, and there's always an additional sill anchor located in each jam. Now, looking at new masonry construction, this would be block wall, brick walls, etc. Extremely common in building construction. The key to this is these walls and the frames are installed and built in very early parts of the construction cycle. So care and maintenance is very critical. Plumbness and squareness is really critical for long-term functionality of the products. On the masonry new construction, there's basically three types of anchors, and again, design will change. The main anchor is the wire anchor, that's that figure 14D, or there could be the metal T anchor, that's the 14C, or the older UL strap anchors that are welded to the frame. They're located based on the chart that we just talked about. The base of the frame is anchored by two types of base anchors or sill anchors, and both jams will usually have one type of these anchors depending on construction. The adjustable base anchor is really designed for installations where there's major irregularities in the floor, or if there is going to be any type of surface topping such as the terrazzo tile or anything like that. The bracket is welded to the frame, and the adjustments are provided by some type of anchor adjustments, screws, etc. And again, that allows for out-of-line floor installations. The other type of anchor that is involved is the fixed base anchor. Right now I'm kind of frozen up here and locked up. 1 second, please. Okay, there you go. The fixed base anchor is another anchor variation where there's no adjustment. It is welded to the back side of the jam just like the fixed or the adjustable anchor. And shimming occurs after the frame is in place and leveled. Now, the anchors, whether it's the wire, the UL strap as shown here, or the T anchor, they're laid into the wall construction as the wall is being laid up. And it'll go depending on the courses of block. And so block is being laid up. The spreader, the mid-height spreader, is adjusted and leveling is always checked. Now moving from the wall as it's being laid up all the way, and then the lintels are attached, the next type of wall anchoring system is the existing masonry anchor. Now in this application, the walls are usually poured in place or they're tilt-up type construction. The rough opening is in place, and the frame is inserted into that opening. The critical part is the clearance between the returns of the frame and the rough opening. Now, in this application, manufacturers may have slightly different rough opening sizes, but basically the opening has to be 1/4 of an inch larger in height and 1/2 inch wider in width than the overall frame dimension. That's from return to return. That will allow the frame to slide in the opening and be squared and plumbed. Usually the existing masonry wall frame is supplied as a welded unit. Once it's slid in place, there is a hole usually in the face of the frame which accommodates the anchoring. A bolt is slid through the face, or I'm sorry, the socket of the frame, through the anchor and up to the wall. Now from there, shims are placed behind the returns, and the frame is squared, leveled, and plumbed. Squaring is critical. Again, the spreaders, both top and bottom, are critical. Then the bolt is tightened into the existing masonry wall. And that would go into any type of anchor shield or a different type of bolt that would accommodate anchoring. After it is tightened in place, totally shimmed and squared, the gap between the returns of the frame and the wall construction are then caulked smooth, and the frame is then finished painted. That's pretty much the existing wall construction. Now moving from the masonry applications into stud wall applications, there are two types of stud walls in use. It's either the steel stud or the wood stud walls. And that's mainly depending on the area of the country. However, the steel studs are becoming far more popular just due to construction requirements. Now, in both of these applications, the frame construction that we're going to talk about right now requires that the frame is installed into the studded partition. After the frame is installed, leveled, squared, anchored, then the wallboard is attached. So the wallboard is the final process in building the wall construction for stud wall partitions. Now, starting off with stud walls, again, this is by far the more prevalent construction. In this, there are different types of anchors, but it's mainly a Z anchor that is welded to the back side of the frame. So you come to the job site with the anchors in. Once the frame is slid into the rough opening, the frame is plumbed and leveled. Then screws or some type of fastener is attached from the stud into the anchor. Now, if there's two ways that these walls are built, if the opening is studded out on the jamb side, both jamb sides, there'll be a single stud. The screws will be attached to the anchor, and then the second stud is installed and secured into the opening. The other way is the frame is anchored, squared, and leveled like a masonry wall construction, and the wall is built around the frame. So there's two types of construction depending on the contractor. Now, once the anchors are installed, the spreader is set at the base and the mid-height. The frame is totally squared and leveled. In the attachment of the frame to the studs, there are recommendations on how to stud the walls, and the contractor needs to really ensure that that happens. Now, there are in HMMA 840 recommended stud wall construction, and this is in accordance with steel stud wall construction. And there's also areas which are not recommended. And inspecting job sites, reviewing back charges in the steel stud, wood stud areas, one of the common issues is the frame throat dimension is incorrect at the job site for some reason. And back charges occur. And this could be related to either trying to insert the drywall, or it actually could be in showing up in defective face surfaces where finished paint will show that there's bubbles in the surface. This usually relates back to the installation and wall construction, where the contractor will put screws in the face of the studs to attach the studs. What this does is it affects the overall wall thickness. It provides interference with the anchors and wallboard. So when you're inspecting a steel stud job, looking at it, it's critical to make sure that the studs are not assembled with any type of face screws in the door opening or the frame opening area. Now, that's a major caution area because it does show up in back charges with all manufacturers, where at the job site have to go back and really look at how the wall is constructed. At the same time, some contractors will use the incorrect method of attaching the horizontal studs to the vertical wall studs. And in that, they will overlap the stud material, which again creates a wider wall than what the frame is designed and ordered for. So it's critical. Now, as the frame is being installed, the contractor has to continually check the squareness, plumbness, and alignment of the frame and jambs. After all that is done, after all anchors are secured, the wallboard is hung and the opening is then finished. That is the steel stud process mainly. Looking at wood studs. Now, these are more prevalent on the West Coast, but the studding process is a little different in that wood stud walls are always studded out and the rough opening is present before the frame is installed. So the wall is usually not built around the frame. In this application, the rough opening is more critical in steel stud walls. It is very similar in sizing as the existing wall opening, in that the width of the opening is the return-to-return overall frame width plus a ½ inch. The height is plus a ¼ of an inch, so the frame can slide into the opening. Now, the procedure for anchoring really is to place the frame in the rough opening. From there, the wall anchors have tabs of some type, whether it's a snap-in anchor with tabs extending outside of the frame, or whether the anchors are channel C-brackets welded in with nailing flanges. But in any case, the anchors have to be bent around the stud. And this step, again, it's a critical issue that the fasteners do not build up the wall thickness like the steel stud frame, or that the flanges on the anchors are not really twisted or deformed, because that will actually space the drywall out and it'll expand the wall thickness. Top of the frame is squared. The bottom of the frame is anchored. And once the top of the frame is squared, it is nailed to the studs on one side. Then the jamb is leveled. It's rechecked for plumbness and squareness, and the additional anchors going down the frame are also nailed in place. Again, it's important that the fasteners are seated properly so that it does not affect the wall construction. Spreaders are installed both in the sill and mid-height. Then the frame is anchored on the opposite side. And again, all the processes, squaring, leveling, ensuring fasteners are seated properly, all that has to take place. That's the contractor's responsibility. After that, the wallboard is installed and it's totally finished. The frame is anchored, squared. Everything is all set for hanging the door in the hardware. That's pretty much the process for the stud wall applications in conventional hollow metal. We're talking conventional hollow metal. That's the frame design that allows the frame to be inserted into a rough opening of a studded wall, whether it's wood stud or steel stud. The anchors are attached to the wall. The frame is squared, leveled, and then the wallboard is attached. That's conventional hollow metal construction and installation. From there, another process is the drywall slip-on frame. Now, these frames are always supplied knocked down. They are never welded because the installation can't occur with a welded frame. The frame is inserted around the wall, I should say. It's hung on the wall, and it's a very easy form of installation and adjustment. And the steps are pretty simple in this. The entire rough opening is set with the wall totally finished. It can be finished painted, or it can be any type of decorative wallboard or anything can be put on the opening. Now, in this, the rough opening is critical, and that goes back to your manufacturer or your supplier. But basically, the steps for installing are very similar. The head of the frame is slid up into the opening, and it encapsulates the wall. The next step, one of the jambs is slid into place. The anchors, the sill anchors, are attached to the frame, or they may be pierces that are in the bottom of the face of the frame that will allow for screwing into the wall sill runner. So that jamb is placed on the wall. The next step is the second jamb is inserted around the wall. Sill anchors are attached before locking in place. The miters are engaged and locked in place. There may be screws required in some manufacturers' corners or in labeled frames. And then finally, the anchoring occurs. Squaring of the frame is accommodated by a compression type anchor that is at the top of the frame. That allows for shifting and adjusting of the frame and plumbing. The compression anchors will vary with manufacturers, but they are designed to totally accommodate either wood stud or steel stud applications. Now, that pretty much wraps up that drywall frame, the drywall slip-on frame construction. Now, just raising an issue in stud wall construction. Steel stud manufacturers have different publications and organizations that publish stud wall construction guidelines. And there's nothing major in these documents to really dig into, but the key is that the gauge of the construction around the door opening is critical. They do recommend 20 gauge studs around the perimeter of the opening. The remainder of the studs in the steel stud application are usually 24, 26 gauge, so this is upgraded construction in door openings. And again, here we're looking at two different associations' recommendations, and they're very similar in this. At the same time, there are strong recommendations on the proper fastenings and locations of those fastenings. Stud type construction and openings is recommended for full height to support the door openings. So, I mean, that's critical when you're looking at stud construction. And if you're looking at job sites, particularly in the current construction where everything is fast-tracked for steel studs, a lot of these studs are really out of plane, they're crooked, and any type of photography when you're inspecting a job will help offset any type of future back charges. And their recommendations also, these go back to the associations of even US JIP recommendations, are double studs around the door perimeters. And this here is very critical for stabilizing the opening and assuring for long-term operation. Now, in additional support information, in openings themselves, just general guidelines, this is still covered in HMMA 840. Large frames, these are transom side leg type frames that exceed the shipping and handling sizes for trucking. These frames are supplied to job sites where they require field splicing. It's critical to understand this is the installing contractor's responsibility. If distributors are now acting as installers, it's your responsibility to make sure these joints are tight, fit snug, and finished properly. If a contractor other than a distributor is doing this, job inspection of joints and methods of attaching are critical. Manufacturers have different componentry for field splicing, but the key in Figure 20 in HMMA 840 is that it's a general guideline used by custom hollow metal manufacturers. Another area of additional information is masonry wall cleanup. These are actual job photos, and this gets into back charges that are critical to control, and this gets into job inspections. These are actual pictures taken by distributors that help offset back charges. In masonry construction, there's a lot going on. These frames are installed really early in the job site. They could be installed like 6 months to a year before it is finished. So rust is critical. When they're installing the frames, it's critical that they remove any type of masonry residue. The frames are always acid washed prior to finishing. It's critical that the acid wash is really cleaned up properly. If there's any type of rust showing up, it's the contractor's responsibility to prime, reprime the products before the excessive rust shows up. This type of picture, and these are actual job photos used in back charges. This is just total neglect by the contractor in the construction phases. It's critical to have the support when the job is coming to completion. And when I say support, I mean the inspection, the photography. Shimming and adjusting. We talked about how to install the frame properly, making sure it's plumb and square. With all that, when it comes time to install the door and the hardware, there will be operation issues requiring shimming of the opening. It's critical to understand that shimming is the responsibility of the contractor. In 840, HMMA 840, there's clear direction in how to shim an opening and how to move the door into the proper alignment so that the hardware performs properly and the door closes properly. Now looking at technical tips in HMMA 840, regardless of the version or the year published, it includes 4 important technical tips related to installation. These tips are critical to offset back charges and to prevent any type of operational deficiencies in the opening. So these are critical things, and they're available, as I said in the beginning, downloaded from hollowmetal.org. Now, in these technical tips, there's one dealing with grouting of frames. Grouting is part of the installation of masonry frames. It is not a required part of installation. It is not a required part of fire coating and labeling, but specifications do require it, and contractors will do the grouting of the frame as the wall is being built up. In HMMA 840, the technical tip for grouting of frames is critical. The key things in this publication is mortar grout is the grout that is recommended. Any type of black plaster grout is not recommended due to corrosion. It's the responsibility of the contractor to not only protect the frame for grouting, but also to do the grouting. Now, the grouting of the frames, they do help in some areas of durability and sound deadening, but it is not a requirement of masonry frames, nor is it a requirement of fire-rated frames, as I said earlier. Now, the big cautionary note in this is in areas of the country where the frames are being installed in lower temperatures, freezing agents are added to the grout. The freezing agents are very caustic to the finishes and the hollow metal. The inside of the frame needs to be back coated with an asbestos type, not asbestos, I'm sorry, a tar type emulsion. Application of the back coating is the responsibility of the installing contractor. Now, in that, some of the manufacturers are offering back coating as an option, but if that's not built into the specification and part of the contract, this operation is the installing contractor's responsibility. Also, another area of back charges is when the frame is grouted. There has to be protection for the door silencers, because many back charges do come up where the installing contractor did not protect the silencers for installation, the silencer hole. That is the responsibility of the contractor unless some type of guard is added into the contract. Undercuts are critical in installation. There is a technical note that covers the correct method of ordering, understanding, and communicating undercuts, because this does become a problem, and you don't realize this until the door is being installed or the hardware and threshold are being installed. So this is a key tip on how to avoid those type of back charges and how to order the correct product. Painting of frames and also doors. This is critical, and we started out with storage of hollow metal. And as the job progresses, the contractor will start raising issues about frames being rusting, deteriorating, etc. Technical tip on painting hollow metal products clearly defines how to do that, and it is the contractor's responsibility through this construction phase to make sure that if the primer is damaged, whether it's scratched, worn, or whether the improper storage is used, it's the installing contractor's responsibility to touch up the primer and repair any defects. That's covered in this technical tip. Again, it's the responsibility of the contractor. Guidelines are on how to, as an industry recommendation, to finish the products in the field as required. Also, we talked last week about transit side light technical tips and in installation of frames with windows in it, hollow metal frames. The technical tip on guidelines for glazing of hollow metal transom side lights and windows is critical. There's clear instructions for the contractor how to caulk the seams properly, how to fill any kind of defects, etc. The caulking of the window lights, whether it's door or frames, installation is the responsibility of the contractor. So this document helps offset any types of future back charges related to transit side light, borrowed light, leaking from weather. I covered at a high level NAAMM 840. It is a critical document with a lot of information in it. This document really should be included in specifications, job specifications. If you're working with spec writers on future jobs, I'd recommend including NAAMM 840 in the spec because there's a lot of guidelines in the spec, and with that, that'll definitely offset any type of back charges related to insufficient or inferior installation. At the same time, working with your contractors, it is a good publication to just familiarize them with it because it will help you in offsetting any kind of back charges. Now again, this document is available from HMMA website, which is hollowmetal.org. It's a free download in a PDF format. We definitely recommend using and promoting this document to your contractors and spec writers. Now with that, I'll just open it up for any kind of questions that are on the document or anything related to HMMA. And I'll turn it over to you if there are any questions that were sent in.
No, Al, I don't see. Oh, actually, we do have a question coming through. Al, how about how long does it typically take to install a knocked down drywall frame?
Depending on manufacturer, their recommendation, depending on the job construction, assuming that that's all as recommended. The drywall frame, the knockdown drywall frame, should be installed within like 15 minutes, really. I mean, they're very easy to install if everything is correct. And it's very workable and easy to adjust. Now, the keys to that is it's got to go into either a wood stud or a wood stud or a steel stud wall. The installation of the wall construction and wallboard needs to be correct. And the size of the frame, the throat opening, needs to be correct to match the wall. if all that's fit, everything should be installed within like 15 minutes. And that's why they're very useful at the end of the job site, where they can be supplied, finished, painted, and ready for installation. Hopefully that answered it, Hannah. Hopefully I didn't babble too much.
No, that's great. We have a couple more questions coming in, one being frames dimpled for anchors.
Could you repeat that?
Sure, frames dimpled for anchors. It does say dimpled.
Okay, I can take that question two ways. If we're dealing with an existing masonry opening, that was one that slid into a precast concrete wall, etc. The anchor holes through the socket of the frame are, there's different ways that manufacturers supplying it. One of the way is it'll be dimpled for a 1/4-20 or a 3/16 bolt, so that it fits flush with the surface of the socket. I'm trying to bring up a detail here so that it's a little easier to talk to. The other way is some manufacturers will supply the products for existing masonry with just a round hole, and with that there would be an exposed fastener, whether it be a hex head fastener or some type of fastener related to that. And this type of hole would not be countersunk or dimpled, however you want to call it. So the first way I would look at that is this type of application for existing masonry. Now, if I can navigate through this again, the other way where a frame would be dimpled for a anchor would be in the drywall type application. And this, we talked about the base anchors of the frame would be inserted into the frame, depending on manufacturer, where the anchorage would take place right through these anchors into the sill runner of the wall. Another variation of that, depending on the manufacturer and how it supplies the anchors, there could be a countersunk hole or a dimpled hole at the base of the frame in the face. That would allow, once the frame is squared, leveled, the base anchor would actually be screwed right through the face into the sill runner of the wall. That would be another way that dimpling of a frame would occur. Now, the only other way that I can think of that would be applicable, some manufacturers offer really focused, dedicated frame construction where it's not a drywall slip-on frame construction, but they would screw through the face of the frame at designated locations right into the wall construction. With that, you would have exposed screws setting inside some type of dimple. That's what I would see as the variations of how dimpled frames would relate to anchors. Hopefully that answered the question, Hannah.
That's
Any other questions?
Yes, we have, and we have to watch our time here. We have about 6 more questions, so I'll start with the next one. Typically, how long to weld a standard 3-sided frame?
It all depends on manufacturer and expertise of the welder. There's a lot of setup as far as on a weld table to square the frame and brace it and everything like that. So I'm not sure how much of that is considered into the frame or the welding. Different manufacturers have different times based on their design. And I would say a frame should be able to be welded within probably, depending on the welder, the expertise, anywhere from like 15 minutes to an hour.
Terrific. How are frames acid washed when installed on the job site?
That is done by contractor, and usually they will be either sprayed or wiped down, depending on who is doing it. And again, it's a nasty operation, but they've got to clean off the residue from the mortar. And you'll even see this type of cleanup in some of the stud wall constructions where patching compound does get on the face of the frame. And in looking at jobs, if that is not cleaned off quickly, even your patching compound will quickly eat out the primer and rust the frame. So I mean, it's usually a spray or a hand wipe process.
Okay, thank you. Well, how about any recommendations on grouting EMA frames after installation? Parentheses, besides don't.
Besides don't do it,
Yeah.
a lot of the contractors will, right at the miter of the frame, they will drill a hole in both miters and pump a more liquid grout into the frame. Now, the cautions on that are that does affect the miter. It does provide a high probability of rusting out the frames, and in many of the existing masonry anchors, they do not allow for the flow of the mortar through the anchors from the top of the frame down. There are some contractors that will install the mortar in the frame. They'll mortar the jambs before they install it in the wall, but it's really not recommended. I don't think there's any manufacturer that does recommend that. It just creates problems and opens up distribution and manufacturers to back charges.
Okay. Does product technical guide for installing metal stud walls also cover the fact that you should not overlap steel and also not have screws on wall thickness?
Yes.
Okay, that was an easy one.
Yes, it does, and that's critical because it gets into repetitive back charges. And if you're supplying product to a stud wall application, that wall thickness is critical, and I can't reinforce enough just visiting the job sites in progress and knowing the contractors. That's the key thing, because a reliable contractor is easy to work with, and they're looking for education on how to offset those problems. Okay. And at the same time, before we go further than that, it's equally important to visit the job site with your supplier, the salesperson from your supplier, to really engage them in some of that process too.
Alrighty. How do you avoid damage to hollow metal frames that were installed early on the construction stage?
Okay, that goes in again. How do they avoid it? Just through care and actually maintenance, really. The care and contractors going through the opening. It gets into the education of the contractor of, hey, once you do this, you've got to be careful because you're responsible. And it also gets into the education of the maintenance as the job is really progressing. Whether it's masonry or stud wall, if damage occurs to the frame, you got to bring that to the attention of the contractor, and they need to repair the finish. I mean, it's just typical construction safeguards. And the storage, probably the storage of the product prior to installation adds more back charge dollars to all the jobs than damage of the openings in the construction process, because contractors just don't repair as they're building unless they're a qualified and reputable contractor. They're easier to work with. So that was a long answer, and I'm not sure if I talked around it or not. And if I wasn't clear, just tell me and I'll try to do that again.
Sounds clear to me. The one final question, Al, as we get close to wrapping it up, our time's coming here to an end. Do HMMA or SDAI cover four-sided frames, such as at roof level openings where an opening is elevated above roof level?
Do they cover it? I think all the manufacturers supply it. The manufacturers should have some type of directions or information about it. HMMA and SDI basically cover it because their manufacturers do supply it. I don't think either organization has actual installation processes or directions for it because it's very similar to a three-sided frame. The four-sided borrow lights, fire windows, window walls, they're very prevalent construction, and all installation, care and maintenance would relate to that. So I'd have to say yes, both organizations do cover it. If there's information that's lacking, that should be brought to the attention of either HMMA through the website or to the manufacturers. I'm done.
That wraps up.
No, that's the end of my answer, I think.
The end of your answer. I think that wraps up our chat session here. I don't see any more questions thus far. And
okay. And in closing, unless you have something else, Hannah, I want to thank everybody for attending this. Hopefully it was worth the time and there was sufficient information exchanged. And I really thank you for taking the time to sit through this at the same time. And I want to thank DHI for the opportunity for HMMA to present it. And also from Allegion's side, thank you for the opportunity. And that's pretty much all I have to say, Hannah. Thank you.
And thank you, Al, for the wonderful presentation today and certainly last weekend as well. And everyone here, the recording will be available hopefully by the end of this week or early next week. We will have it available, and there will be handouts as well. And certainly you can go to dhi.org/education to see the list of our upcoming webinars, and be sure to sign up for each session individually. And again, thank you for attending today. And again, Al, for your expertise and time. Thank you all. Have a wonderful day.
Thank you all.